during the day. Good, since we can't record. I was engaged in a lot of activities during the day, so we couldn't start on time. But let us see how far we can go. The last time that we met, let me find out. Were we all in attendance? The last time we met, were we all in attendance? Okay, that was funny. Were we in attendance? Good. Okay, so did we reach there? If my memory serves me right, did we reach somewhere? Did we reach there? Can we please find out? Did we reach there? Okay. Where exactly did we reach? Did we take down of a page that we reached? Did we take down of a page we reached? I personally didn't. Fafa, did we? Did we or did we not?
I think we ended on compatibility.
Compatibility. Okay. Thank you. Okay. Oh yes. 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 You're right. You're right. You're right. So like our culture always, please get your pen, a paper, a pen and a book, so that we talk about that. Just give me a thumbs up once you get the materials. Just give us a thumbs up. Have we gotten what right? Okay. Just give me a minute. Okay, so let us start. First of all, um, I stands for, please, if at all you're writing, let us start from there. I stands for intention. Okay, I stands for intention. S stands for shared. Okay, S stands for shared. X stands for exclusive. S shared, I intention, X exclusive. Okay. Okay. Let us start with the third one. Let us start with the third one. Intention shared. Intention shared. Intention shared. Okay. Okay. Just skip about maybe three lines. Three lines. There's something that we haven't said. So I hope you've skipped. Can we proceed? Just to skip 3 lines. Okay, good. So let us start with this. I stands for intention. Intention, which means about to. Which means about to. So you intend to do some work. Okay? Intention, which means about to. S, S, which is shared. S, which is shared, means read. Okay? Means read. So only a read can be shared. Only a read can be shared. X means exclusive. X means exclusive or stands for exclusive. X, we put the records right. X stands for exclusive, which means a write. S is a read, X is a write. X stands for exclusive, which means a write. A write can't be shared. That means X can't be shared. Okay? Now, we can continue with SIX shared with intention. Okay, let's okay, we'll come back to that. Let's go back to IS. Intention shared, intention shared, intention shared, intention shared. Okay, so we are on intention shared. Intention shared, when you write intention shared, which is IS there, down you can write, I intend to read some rows in this table. Remember we said about to. Okay, so it requests a read. So below intention shared, which is IS, you just say, it means I intend to read some rows in this table. I intend to read some row in this table. Okay, that's the meaning. When does it used? Okay, when do we use it? That's a very important question. So when do we use it? So we use intention when the S, or when we want S. When we want S, remember S is shared, which is a read. We use intention to read. Okay, so we use intention shared when we want S, which is a read. When we want S lock on rows. So when we want S lock on rows, we use IS. Okay, we will come back to this. First of all, we take note of this. Okay, then we can come back to intention exclusive. Intention exclusive, remember exclusive is writing, which is making changes. Intention exclusive. Hope I'm not too fast. Are we good? Fafa, are we good? Okay, good. So we come to intention exclusive. Intention exclusive, you write intention exclusive, which is IX. What it means. So down there you write what it means. Remember, there is exclusive there. So IS was this. So this is I want to read. Okay, that is what it means. IS. S is shared. So a share is a read. Here I want to write. Okay, I want to write, or I want to update. I want to write or update. I want to write or update. I want to write or update some rows in the table. That's intention. So you intend to write or update some rows in the table. Okay. Then we come to shared intention exclusive. Okay, so we come to shared intention. That means shared plus intention exclusive. Shared, that it is read as a shared with or shared plus or just shared with intention exclusive, SIX. Shared with intention exclusive. Okay, remember shared is a read. So what it means, once you write that, you say what it means. Under what it means we write I am reading. That is shared. I am reading the whole table. I am reading the whole table, which is WHOLE. WHOLE. I am reading the whole table. Okay. But that is I want to write. So but I want to update some rows. I am reading the whole table, but I want to update some rows. Okay, I want, you have intention to make changes. That's when now we can talk about this compatibility there. Does that make sense there? Okay. Does that make sense? Yellow? Okay, good. Okay, so these are locks. Exclusive lock is not shared. Okay, that's what we mean. Intention, intention exclusive is only compatible with intention exclusive because exclusive lock can't be shared. Okay, so it is compatible with intention exclusive. Once you make updates, you can also read those updates. That's why it is compatible with IX and IS, but not with shared or exclusive alone. Okay, I am reading the whole table, but I intend to make the update. So this is compatible, okay, with, okay, there is this reading happening. So intention shared because you are reading. So a read can be shared. That is S there. S shared, which is a read. So I intend to share, but not to write. Okay, so it can be shared by that standard. You can also write to by that standard. Remember, exclusive lock can't be shared, so you don't intend to share. Okay, now this one you intend to share, which is a read. It is compatible with intention to write. You can read there, then you make updates. You can also share. You can also intend to share. You can also share because a read is shareable, but you can't just exclusively write. Does that make sense? Okay, good. Yeah, I think we've labored there. Locks did not enforce serializable. Why? Okay, that's not important for now. Okay, so look at what is happening here. Look at what is happening here. So transaction 1, this is transaction 1. This is transaction 1. This is transaction 1. Okay, so L means a lock. Okay, so 1 here is that transaction number 1. So transaction 1 acquires a lock on A. Transaction 1 acquires a lock on A. Transaction 1 acquires a lock on A. Okay, so we get a lock so that transaction 2 doesn't get that lock. So it's a situation where I think last time we used, for example, the bathroom. You go in the shower, you go to bath. You make sure you lock that door so that no one else enter. So we don't want a transaction 2 to enter there. So once a lock is acquired on A, we can read, transaction 1 can read A, then assign to T. After assigning to T, we can add 100 to T. Okay, so I want you to assume this. Assume T is 2. So assume T is 2. Okay? I mean, assume A is 2. Just assume A is 2. So when we get a lock, transaction 1 gets a lock on A, which is 2. Then transaction 1 reads 2 and assign to T. So T becomes 2. So when we have 2 there, we add 100 to 2, it will be 102 and assign to T. Then we write transaction 1 write means updates. Okay, so it updates that 102 and assign back to A. So A become 102. Then U means unlock. Then after updating, transaction 1 releases a lock. So you acquired a lock, you release a lock. That's when transaction 2 begin. Now transaction 2, since it was locked, as long as it is not released, it can't go there. So transaction 2 now acquires a lock on the same A. So A is 102, remember. Okay, then transaction 2 writes writes A and assign to S, which is 102. Okay, now this is 102. Then 102 by 2, this will become 204. So our S will be 204. Then we sign back that 204 to A. Then we release. So this become 204. A there is 204. Please pardon W there. That was supposed to be R. So A is 204. Let me ask a question. Have we followed up to this point? Have we followed up to this point? Dan, have we followed up to this point? Okay, good. So A is 204 there. Then we release a lock. Then transaction 2 gets a lock on B. Assume B is 2 as well. Get this, A is 204. So this is 2. Then we read 2 and assign to S. Then S by 2, which is 4 there, we assign to S there. Then we assign back that to B. So at this point B is 4. Okay, B is 2, we lock. We read assign there, it becomes 2 by 2, 4. Then that's 4, we release a lock there. Then that's when transaction 1 gets B, reads B, assigned to that. So now remember at this point B is 4, so that is 4 plus 100, that is 104. Then 104 assigned to B. Then B, the lock is released on B. B is 104, A is 204. Are those results same? Are those results same? Are those results same? Are those results same? Yellow, are those results same? Were we following? Were we following when we were doing some calculations there? Okay. What was the result of A? Okay. Okay. Let's do this once again. Please pay particular attention. We are saying assume A is 2. So you start with, you test with same numbers. So you write A there is equals to 2, B there is equals to 2. Okay, so we acquire a lock on A, then we read, transaction 1 reads A. So it reads a 2 there. We assign that to T, then T 100 is added to T, which is 104. Then this become 104. Once we write, we update. This is 104A. Okay, A is 104 there. Now the lock is released on A. That means transaction 2 can acquire that lock on A. But at this point, A is what? A is what at this point? Do we have people in the meeting? Do we have people in the meeting? Please let us interact a little so that we know whether we're making a progress or not. Are we following? Are we really following? Let us interact a little, please, because I don't know whether you guys are following or not. If we can't interact, then please, let us interact a little, because while we are going, we are trying to dive deep into advanced databases. So when you start, you have two transactions, and you have the field A, you have field B. So at a start, make those fields test, okay? Both set to the same value. So at this point, the value that I have chosen for us is 2. So A will become 2, B will become 2. That means transaction 1, that one represents a transaction, acquires a lock. This is a lock on that field A. But what is A? Yellow? Good. Good. A is 2. So we read A. The purpose of acquiring a lock is to make sure that the other transaction doesn't interfere in that. So we read, reading means checking. Once we read A, which is 2, assigned to T, then to that T, 100 is added. Then we have what is this T plus 100? What value do we have? What value do we have? Okay, good. Just give me a minute. Okay, so we have that. Okay, so we have 102. Then we write 102. That means assign that 102 to A. Okay, then we release a lock on A so that transaction 2 can get it. So here we acquire, here we unlock. This is unlocking. So transaction 2 picks up a lock on A. So what value of A has been picked up? Can we interact a little? One zero two. Then there is a R, which is read. So we have that. Okay. Then we do this 102 multiplied by 2. Which value are we going to have? 204. Then we assign that 204 to A and release that. So you're going to find that at the end of it, or A will be what? Can we interact a little? What is A? Guys, are we in the meeting? Please go ahead. Yes, the new A at this point. 204. Keep that. So we pick up a lock. Transaction 2 picks up a lock on B. But what is the value of B? What is the value of B? 2. We've chosen 2 right from the start. Okay? So that is 2. Then we read. Then we multiply there. So this will be 4. Then we assign 4 back to 2 and release. Release a lock so that transaction 1 can pick up B. So what value of B is transaction 1 picking up? Huh? 4. Good. Then we read transaction 1 read B, assigned to that. Then T plus 100, what value are we going to have at the end of this? What value are we going to have at the end of this? 104. So you would find that B is 104. A was what? 204. Now we started with the same values, 2 and 2, and the end result is 204 and 104. Do you remember the definition of conflict serializable? Do we remember the definition of conflict serializable? So you start with the same values. If the end result is the same, then that is conflict serializable. Okay? So in this case, A is 204, B is 104. This lock did not force, it did not enforce conflict serializable because of that. So that is how to look at that. That's quite important. Have we understood that? Okay, please go ahead. Exactly. Yes. It's not conflict serializable. Exactly. So when the values at the end are the same, that is conflict serializable. I wanted to send you a question last time, like I said, but I realized we haven't looked at enforcing, we haven't looked at committing, so I can't send that not until we look at the commit and two-phase locking. Okay, so uh, did did this log enforce conflict serializable? What you do is begin testing. Okay, so just get look at what you're dealing with. You have A field, you have B field. Start with the same values. Okay, A2, B2. Again, it's not me to choose for you. Okay, you can choose values, but find values that are that resonate with you. Go through that so that that picks up. Then go through that so that that picks up. If at all these two are the same, okay, then the locks enforces conflict serializable. Does that make sense? I can't see your thumbs up. Just unmute yourselves. Okay. Papa, does that make sense? Okay. Okay, so that is the explanation there. So T1 acquires a lock on A and releases it. Okay, before acquiring a lock on B. That is just the explanation as to why that happens. What is the correction? Please, the correction is called two-phase locking. The use of two-phase locking. Just read that explanation that I put for you. Okay, so two-phase locking. Two-phase locking is what we are calling a growing phase and a shrinking phase. So in a growing phase, a transaction only acquires a lock. It does not unlock. Okay, no unlocking. In shrinking phase, a transaction only unlocks, no locking. So there are two phases. Look at it like a graph. So you have this graph here. Then there is this guy which is rising. Okay, so in this rising we are calling it growing phase. Then it begins coming down, we are calling it shrinking phase. So in growing phase, a transaction only acquires locks. So it just keeps on acquiring locks, not until it reaches there. Then it begins releasing those locks, not until it reaches towards the ground. Okay, that is what we are calling two-phase locking. Okay, so two-phase locking is a locking mechanism which has the growing and shrinking phase, in which a transaction only acquires locks in that growing phase and releases locks in that shrinking phase. It's a locking mechanism. Okay. So in every transactions, all locks acquire all locks requests must precedes that is all requests for locks must come before or unlocking request. Okay, that is what we are saying there. So this is what okay. This will take us even up to next week. That's what I see. We've spent about 44 minutes and they are calling me. Badness of being home. Please take note of the page 10. Maybe we start from here on Tuesday. They are calling me to do some work outside. I'm really sorry. Please take note of the page so that we do that. I have to rush. Really sorry. We'll come back to campus soon. I hope you don't have a question before I just log out. Do you have a question? Please go ahead. What is the purpose of two-phase locking? Oh, the protocol is a rule. Okay, so when we talk about the protocol, we're just saying rules. So the rule is all locking. Okay, if you need locks, all that locks must be requested in growing or rising phase. If you need locks, all those requests, you need to make a request. Those requests must come in growing phase. That's the protocol. If you are releasing locks, all locks must be released in shrinking phase. That's the protocol. That is, in every transaction, all lock requests must precede all unlocking requests. That's the protocol, and that's the rule. I don't know whether I've answered your question or not. Have we answered your question?
Yes.
Okay. I have to rush. I'm really sorry. Maybe you have another question before we just call it a day. Do you have another question? Okay. Okay. Do we have a question? Danny? Okay. Okay. See you next week, Tuesday. Sorry, I have to rush.